Alright, so before I begin, I would like to give credit to the physics department in our school, specifically Miss Eastep and Miss O'Kane, for helping me gain the knowledge to help create this lesson. So my first lesson for physics honors will be the review of the summer assignment you guys would have gotten on the last day of the previous school year. Okay, so two of the main things that you first learn are what scalars and vectors are, and this is important because you will be using this knowledge for basically the rest of your entire year. So it's important to know that scalars only show magnitude or size, and some things that are scalars include mass or distance. On the other hand, vectors show both magnitude and direction, and they're usually denoted by an arrow. Some examples of vectors are forces or velocity. So some properties of vectors include that, like I mentioned before, they show magnitude and direction. The size of the arrow indicates relative magnitude. So a larger arrow would mean a larger vector, and a smaller arrow would mean smaller vector. The arrow point shows direction. So normally we measure the angle from the horizontal. So by measuring the angle from the tip of the arrow point to the horizontal, you can determine the direction of the arrow. And you can shift vectors around to different locations, but as long as the direction and the size are the same, it is still the same vector. It does not matter where the direction of the vector is. So one of the more difficult things you might have faced in your summer assignment is how to convert between polar and Cartesian coordinates. So polar coordinates are represented by the first quantity is the magnitude of the vector. The second quantity is the angle, which is the direction of the vector. So as you can see here by this graph, I have a vector that starts at 0, 0, and then the arrow points to 10, 7. So this graph shows the Cartesian coordinates of the vector. And what we want to do is we want to convert from the Cartesian to the polar coordinates. So I have here 3 really easy steps to make this a really simple and quick process. So the first step is to rewrite the vector into component form. This is basically the change in y comma the change in x comma the change in y. So in this specific case, you just do x2 minus x1, which is 10 minus 0 or 0, and y2 minus y1, which is 7 minus 0 or 7. So for this specific example, the component form of this vector would be 10 comma 7. Now the next step is to use the Pythagorean theorem with the component form to get the magnitude of the vector. So you just do 10 squared plus 7 squared, and you take the square root of that. So whatever value that is the magnitude of the vector. And then the last step is you take the inverse tangent of the y over x value to get the angle. So in this case, you just take the arctan, or the inverse tangent, of 7 over 10, and that is your direction. And this is how you convert between polar and Cartesian coordinates. So converting from polar to Cartesian is a lot easier in my opinion. So first you have the r comma theta, which is your angle, that's in polar form, and now we just want to convert it to Cartesian form. So all we have to do is just first you take the r times the cosine value of the theta for your x coordinate, and the r times the sine theta for the y coordinate. As you may remember from previous years, the cosine value corresponds to the x, or the horizontal, and the sine is always corresponding to the y value. So this is why cosine is always first before sine. And one example that I have here is 5 comma 53.1 degrees in polar form will now become 3 comma 4, about 3 comma 4 in Cartesian form. So thank you for listening to my presentation here. I will have more videos for you later.